Well, there it is, KP the Math G, and I've been trying to set my camera up. Just by the time I turned it on just a while ago, it went up a little bit, so I've had to adjust. So I appreciate everyone tuning in. I am KP the Math G, and today we're going to talk about indefinite integrals. We're looking for a particular solution for C. In other words, we're going to solve for C. And what we're going to do in this particular first example, we're going to find particular solutions from f double prime to f prime, and then from f prime to f if we have this first condition, okay, initial condition, f prime at pi over 2 is equal to 5, and then the second condition, f at 0 equals 8. A little bit of a reminder here about what we're trying to do is if we start off, and then we are starting off with f double prime, and just to put this off on the side, if you take the antiderivative of that, you do get, oops, I always do that. I don't know why I do that. I just always seem to want to write it like that. You get f prime at x, okay, and plus c if you want to do that. So we could do that. But if you take the antiderivative of f prime at x, you get f at x, okay? So remember when we were going backwards, and then plus c, of course. But then when we work backwards, you remember the derivative of f is f prime, and the derivative of f prime is f double prime. So now that we're doing the antiderivative, we're actually going the other direction. Okay, that's what we're doing here. And if you hear a little jingling, it's because my cat decided to come in and watch the lesson with me, I guess. Anyway, alright, so let's take this. We're given that f double prime of x is equal to cosine of x. So what we want to do is get down to this f prime. That's what we're looking for right here. But we got to do that, we've got to take the antiderivative of f double prime as I showed you before. We're going to do that to both sides. Alright, there we go right there. Okay? And that's what you got to start off with. Because you want to get down to f prime because f prime is at pi over 2. We want to figure that out. It's equal to 5. We want to get down to that. Okay? Well, let's take this. We know what this is. This is f prime at x. Okay, that's what that is. And then this side, remember the antiderivative of cosine from our previous lesson is sine. Sine x plus c. Okay, now I can come to this first one right here. I'm not worried about this second one because I'm at f prime right now. Alright, I'm at f prime, and so I'm going to go to this this initial response here. Okay, this initial condition. That's what it's called. Alright, so f prime at pi over 2 is equal to sine of pi over 2 plus c. Now, of course, sine of pi over 2. Oh, what's that? I hope maybe at this level that you can remember what sine pi over 2 is. It's kind of the same. Remember pi over 2 is the same in degrees as sine of 90, which is 1, isn't it? And of course, if you were to draw a picture of the graph of sine like this, you see that here's 0, the next one that's more important is pi over 2, and that answer, that y value is 1. It corresponds to 1, doesn't it? Alright, so we're saying that f prime pi over 2, we know that says 5, so we're going to put 5 in that place. Let me erase this. Okay. We're going to put 5 in that place. That's what it says, f prime at pi over 2 equals 5. Okay, so 5 in that place is equal to, we already established that that's equal to 1 plus c. See, we are finding a value for c. Alright, right now this is the general equation. What we want is a specific equation. Like I said last time, we could substitute in place of c any number we want. 0, 1, 2, 3, 4, 5, -1, -2, -3, and so on. We could put in, if we want to, pi over 4. We could put in whatever we wanted to, the square root of 2. But that's general. Now we're going to come to a specific number, and that number is 4. Okay, now it's not just a general number here, not just anything we want. It's not what sine is actually doing. The sine wave is, you know, the bigger the number here, the more higher it goes. The lower the number, the lower it goes here. That's all that's doing here. And in this case now we have f prime at x is equal to sine x. No more do you put the pi over 2 in. You use that to find what 4 is, or find 4. So now plus c, which is, well, c is 4. Alright, there it is. And that's f prime at x, right there. Sine x plus 4. Okay. Now remember, we want to find f at 0 equals 8 as well. Well, we first had to take that antiderivative of this double prime to get the single prime here, didn't we? And now we're going to take that single prime off, and we're going to get down to just f. So let's do that. I don't want to turn this board over. I'm just going to go ahead and erase this part right here. We're going to go from f prime to f now. Alright, so we have this time given f. We done found that f prime at x is equal to sine x plus 4. And now we want to take the antiderivative, alright, like this, like we did before, antiderivative of sine x plus 4 dx. That's what we want to do. Okay, there it is right there. We'll erase it now, because we're going to need the entire board. Okay? Alright. Are you with me now? Alright, so we took the antiderivative of f prime to get f double prime to get f prime. Now we want to get f. It's kind of like, you remember when you have the let's say when you have the acceleration, you take the antiderivative of acceleration, what do you get? You get velocity. And then when you take the antiderivative of velocity, what do you get? Well, you get the distance equation, or you get the position function. Okay? Alright, so that's what we're doing here. Alright, well, let's see what we get here. We know that the antiderivative of f prime at x is just f at x. Alright, and this is negative cosine of x. Remember now, the antiderivative of 4 is 4x. So if you have 4 dx, that's just equal to 4x. Well, plus c. Alright, so we're going to add 4x plus c to that now. Alright. Alright, so now that we have this, we're done with this one. We've used this one to find this 4 right here, didn't we? Alright, so now, wherever my eraser is, okay, Now we're going to use what f at 0. So f at 0 now, let's get a different color. I don't like to use the same color throughout a lesson. How about this one? Okay. So now we're going to find f at 0. F at 0 is equal to negative cosine of 0 plus 4 times 0 plus c. Oh, we squeezed it in, didn't we? Well, let's see. F at 0 is said to be 8. Alright, so 8. Alright, now, whoa. What is cosine of 0? Well, we have a negative cosine of 0. Well, if we knew what cosine of 0 is, we can take the negative of it, and we'll be alright, won't we? Let's think about the graph of cosine. Let's look at that real quickly. Here is the graph of cosine, like this, okay? A rough sketch, okay? Here is 0. We know that that answer is 1, isn't it? So what we have here in this particular case is, remember this is pi over 2. Alright, cosine of pi over 2 is 0. Cosine of pi is negative 1 right here. And 3 pi over 2, cosine of 3 pi over 2 is back to 0. And cosine of 2 pi is back up to 1. Okay. Alright, anyway. That really wasn't all that necessary, but it's good to know all those things. Alright, so cosine of 0 is 1, but remember this is now negative, so negative 1. Alright, so there it is. Alright, so let's see. Back to red. So negative 1 plus 4 times 0. Whoops, plus sign. Let's move it out a little bit further. Plus 0 plus c. Alright, so 8 is equal to negative 1 plus c. And then just add 1 to both sides. Plus 1. So now c is equal to 9. So in place of this c right here, I'm putting 9. So now f at x then. F at x is equal to negative cosine x. Now remember, don't put anything in place of these x's. Don't put the 0 there. You use the 0 to get the 9. Alright, so plus 4x. Alright, plus 9. And that's it. That's the final answer that we're looking for here. Alright. Alright, that's using this twice, isn't it? So you take the antiderivative of f double prime to get f prime, and then you take the antiderivative of f prime to get f. And that's what you're doing here. Okay, you use the f prime to get 4, and then you use the f to finally get 9 here. Okay, so it expands a little bit, gets a little bit bigger and bigger. Okay, alright, there it is. Alright, so let's do one more. Okay, I think we have time. This is Sunday. My wife's at church. Well, long story short, I got off. I came home early. I attend a different place than she does, and I'm just waiting for her to get out. But needless to say. Alright, now we're going to do something with acceleration and with velocity. And what we're trying to do is we're trying to get to the distance equation, or what we might look at as or refer to as the position function. I keep forgetting that's what it's called. It's called a position function. All right, that's what we're trying to get to. So let's paint the picture for you on this one. All right, so in this particular case, we're going to go ahead and just lay out the conditions for you. Let's do that now. Okay, so in this case, we have an initial condition, A at 0 is equal to negative 32 feet. We're going to go with feet and seconds, so feet per second squared. It's negative because we're talking about gravity. Okay. Okay. The initial velocity, so v at 0, we're going to say is 640 feet per second. The initial height is that's S. That initial distance is, it's like, okay, it's 100 feet. Now, I can write the equation of this right away. Well, almost right away. Okay, but not quite. Okay, so what we're saying is we want, alright, we want that function there, that distance or that distance function or the position function. We want to know what is that. Okay, we start with acceleration and then we work our way up to this position function. Alright, so when we take the antiderivative of the acceleration, we get the velocity, v at t. Alright, so let's see if we can get to that. All we're given is this initial condition right here, aren't we? Alright, so we're saying then that A at t is equal to negative 32 feet per second squared. Alright, so feet per second squared. Alright, so now what I want to do is find v at t, which is A at t, well, the antiderivative of A at t, alright, dt, alright. And so what I'm doing here is I'm going to do this right here. A at t happens to be negative 32 dt. Alright, that's how you set up the first part. Okay. And all that is when you can put this negative 32 on the outside if you want to, and you just have dt. When you take the antiderivative of dt, that is just t. Alright, so that's equal to negative 32, and just put a t on the end, and then plus c. That's it. So what have you found? We have found v at t right there. Alright, v at t is equal to negative 32t plus c. Alright, well, alright, so that's where we're at right here. Alright? Okay. Okay, so let's go ahead and plug. We want to find out what C is. So let's find C. Alright, so my wife is here. Okay, she just came up. Okay, so we're going to have a little noise. Okay. She is knocking on the door, playing with me.
Don't open it.
She said don't open it. Well, of course not. I'm not going to open it. Okay, so let's find out what C is, given that V at 0 is equal to 640 feet per second. Alright, so if we say V at 0, we're equaling that, that's equal to negative 32 times t. Now t happens to be, well, let's see. Let me think about it just for a little bit. Oh, okay. Yep, we're plugging in 0. That's the initial time, okay. Yep, that's 0. Alright, so plus c. Alright, we know that b at 0 happens to be b at 0 happens to be 640 feet. So yeah, alright, it's been like 2 or 3 days since I've looked at this, so bear with me. 640, alright, is equal, so v at 0 is 640 feet per second. We'll put the units down. That's negative 32 times 0 plus c. So we're solving for z. This is 0. So c happens to be 640. And that's the way it should be. Alright, so here we go. Let's write our equation out. So now what we have is v at t is equal to negative 32t, and before that we had a plus c, so we found out what c is. It happens to be 640. Alright, like that. So that is v at t. A at t, negative 32 feet per second squared. Okay, when we took the antiderivative of a at t, we simply just got negative 32t plus c. And again, that plus c is important, otherwise we can't complete this problem. Alright, it makes sense right here that that's what it is. Alright, so that's v at t right there. That is the velocity equation. Okay, given these conditions right here. Okay, alright, let's write this down. I think maybe we can flip it over and write this down again. V at t is equal to negative 32t plus 640. And again, time t is 0. Alright, and that's always the initial, that's when we talk about initial acceleration or initial velocity, time t is 0. Okay, usually it is. Okay, that's initially. Alright, and so what happens is that something is being projectile from a height of 100 feet. Okay, it's projected up and so on like this. So what we're looking for is the position equation. We're finally wanting to get down to this. And I should have had it written out, but I didn't take time to do that. Alright, so let's go ahead and write this down. Let's flip it over. We're almost done here. Let's flip it over. Alright, and let's rewrite what v at t is. V at t is equal to now negative 32t plus 640. Alright, there it is. Alright, now what we're trying to do, we're trying to find the position function. Alright, so s at t, that's what we're looking for, is equal to the antiderivative of v at t dt. That's what that is. But it so happens that that's equal to negative 32t, negative 32t Alright, negative 32t plus 640. Alright, there it is. That's s at t. Alright. That's the antiderivative of that. So let's figure out what this is now. Alright, so this is going to be equal to, now we're integrating. We don't need the integrating symbol anymore. Okay. So at this point we're saying, okay, so let's see, negative 32 t squared. Remember when that's to the 1, we add 1 to it. We're going to divide by 2. So after we add 1, we put that in the denominator. Remember that, dt, oh my goodness, put that there. Alright, so now plus 640. Remember, if it's just a constant, you just simply put the letter out there, so that's t. And then now plus c. Okay. Alright, and then of course negative 32 over 2 is negative 16, and that's usually what you find on this kind of equation. T squared plus 640 t plus c, and we are now, this is s at t, alright, we want to find s at 0, alright, so let's plug that in. We know that it says that s at 0, the initial height is 100 feet. That's what that means, initial height is 100 feet, okay? You're not starting on the ground, you're 100 feet high already when you shoot this projectile up in the air. Okay, so now we're at 0, so s at 0. S at 0, we're going to put a 0 everywhere t is. Alright, plus 640, 0 plus c. Alright, notice that this is just 0 and this is just 0. And s at 0 is 100, so we're going to put in 100 is equal to, well, that's equal to c. And that really makes sense because we have everything together. The initial height is going to always be at the end, okay? The velocity, the initial velocity, is always going to be in the middle, and then the acceleration due to gravity is always going to be at the front, and something squared. It's usually that's the case. So our final answer is going to be then s at t. That's what we were looking for. Alright. Our position equation is equal to negative 16t squared plus 640t plus 100. Okay. We found that using calculus. Okay. So the only thing that you just have to do, you just have to remember what the initial conditions are. So we started off with a at 0 being negative 32, just a number, right? And that was in feet per second squared. And then we got v at t, all right, to be negative 32 t plus c, right? Just reviewing. But we found c to be equal to, and remember that initial condition was v at 0 was equal to 640, okay? All right, so that's what we did. So when we put the plus c there here, we just simply did 640 is equal to negative 32. That's actually v at 0. All right, and then plus c, and we found that c was equal to 640. All right, and so we had an equation that extended a little further out. V at t is equal to negative 32t plus 640. Okay, and then we found that s at t, once we did this and we found c, we found s at t, well actually s at 0 to be equal to 100. Alright, and so what we did, we took the antiderivative of v, we found that right here, that's what that is here. We found that equation here, and we solved for c. So we just simply plugged in 0, 0, 0. C is equal to, of course this was 100, s at 0 was equal to 100. So that's what we did. And then we came up with c being equal to 100. So actually we took the antiderivative and we got this. So now s at t is equal to negative 16t squared plus 640 t plus 100. And if you look at this, you can easily see where the velocity is right here. This is initially how high it was. Okay, you're at a height of 100 feet, whatever it is that you're looking for or that you already know. You already knew this is 640. You always put your velocity in the middle. And then, of course, you have to find this. It started off with negative 32. We had to wind up with negative 16t squared. But that's generally what you do right there and in finding all of this. Okay. So that does it. I mean, the idea is you have an initial condition, and you have to, in this particular lesson, we had to take the antiderivative twice. Okay? All right. And my magnet keeps falling out of my eraser, so I'm just going to have to glue that back in one of these days. Get that glued back in, and it just keeps falling out. But anyway.